Device start here, but we're ready to start the technical steering team meeting today. And Satish is going to present number of proposals for enhancements to the various ONOS subsystems in order to support the various use cases. So Satish, I'm going to just let you take it from here, okay?
Sure. Yeah, you can see my desktop. My screen is visible.
Yes, now yes we can. Let me mute our side so that we don't keep swapping here.
Sure. Yeah. Good morning, everyone. Yeah, this is about actually our use case is the BGP link state distribution SPA plugin, which we have been adding in our email release. Okay, as a southbound. So in this, as a BGP LS protocol, we'll be learning the link state topology information as well as the T parameters from the network, underlying network. So, and using the information, we'll be building the topology into the distributed core of ONOS. This topology will be used by the applications like PCE in future, which will be built at the application layer. So this, or it can be any other application which uses this topology information. And one of the use cases is like as like PC uses this topology to complete the path between the ingress and egress, and with the given constraints like T constraints like bandwidth and cost, etc. Okay. So once the path is computed by PC, it can set up a tunnel using precept SBI, which we already have now. Okay. This is one of the use cases which we are trying to address now. Okay. So actually, to push this topology information, we face some of the difficulties in the current interfaces which we have with the core. Okay. So before going to that, we'll see like how the abstract network and abstract topology modeling is done in IETF. Okay. So this is the IETF draft currently present for I2RS Young. This is the Young model for I2RS to represent the network topology. So if you see this, we have the abstract network model, which consists of the nodes, basically it's the devices, and the abstract topology model. So it contains about the links and termination points between the links. Okay. So further, these are the abstract level, and further this has been extended for L1 topology model and L2, layer 2, layer 3, and even it can be extended for service topology model. Okay. So further, the L3 topology model can be further extended for OSPF topology or ISAS topology, and with the traffic engineering information as well. Okay. This is how the current IETF draft has been defined, and Young has been modeled. Okay. And this supports the multi-layering, like we have optical layer 1 and layer 2 and layer 3, and even at the service level. And there is an interaction and there is a relationship between the nodes of the logical nodes to the physical optical or layer 3 nodes with the services. Okay, this is the current IEEE standard for this. And if you see the Young abstract topology Young, you can see that we have the topology ID, the list of can be multiple topologies, and each topology can have its own topology ID, and it's having the underlying information, which is the reference. It can be optical or anything. And you have under the topology, network topology, we have nodes. So basically, in our case, this is all the devices, what you're talking about. So this is the devices of the actual network. And this has only the node ID, and it has the reference to the other devices in the other topology. So underlay, maybe the underlay part. And also we have the link. And the link, if you see link ID, and the link ID is now the source and the destination, node information, and the termination point, if it exists, and it's the link reference. So this is the abstract Young is represented in case of IETF draft. And further, they in the IETF, the concept is they augment this abstract model with the when they talk about L3 IGP topology model, they abstract it with L3 information. Like for example, the basic information remains same, and the L3 information they augment to it. Like when it comes to termination point, So here they augment the IP address. Either it can be IP address or it can be unnumbered interface ID. Okay. Also, when it comes, also they augment the IGP node attributes like name, router ID, and we will also have multiple prefixes, list of prefixes in the node, and as well as the link attributes. When you talk about link attributes, we can they also augment it with the metrics information and other topology attribute information into this. So this is how the current IETF has been modeled to represent the topology. So this is a generic topology in which they can use this mechanism to represent any topology information, starting from layer 1 to service topology model. Okay. So now I face difficulties when we come to the our ONS interfaces which has been defined. So if you see our ONS thing, the interfaces of device or link subsystem. Um, First, I'll take it about the device service, device subsystem. In the device subsystem, the device provider service, we have all the informations which is specific to layer one, layer two, basically the open flow switches. So if you see the device, if you take the device interface, it is more specific to the base information like device ID, manufacturer information, and software and serial number, chassis ID information, and also default device descriptions like yeah. So in the default device provider service, sorry, yeah. So in device provider services, we have something called device connected, and it contains the device ID and device descriptor. And again, the device descriptor is specific to the open flow switches in this case. Also, we have a method to update the ports. So we have the device ID, and we can add the list of ports associated with the device. So and again, this port description, if you see further inside this class, we have the port number, and again, this is the final class. So if we talk about the L3 and other service layers, we won't be having any port number as such. So I feel it should have been more generic. It shouldn't have been any specific to the layers. It should be, instead of port number, it should have been generic information. So maybe like termination point, which is having only the ID. And when we talk about layer one, we can put port number. When we augment it with layer three, we can put with the interface. So when we talk with service, we can put some other information related to service. So by this, our interface would have been more generic. So it is the same case with case of link. So here also, if you see the link detected, so we have the link descriptions and connection points. If you see again, the connection point contains. Okay, this is the element ID. It can be extended for the device, or I think it's already extended for the device. And if you see again here, you have port number, the device, the element info, and the port info is part of the connection point. So again, this port info is specific to layer one, where we have the. This is the final class, which can be extended further to any layers we want to add. Okay. So this is one limitations which I saw in the current interface which we have.
So I have a quick question. So you mentioned open flow specific. What?
I mean to tell switches specific to the switches. Like it has very bare minimum like hardware information, software information, and the manufacturing information of the devices. So
yes. So it's done on purpose. That way, its devices here represent essentially the pieces of iron that that participate in formulating the topology, whether they are switches, routers, ROADMs, wireless radios, or whatever. They're still devices. And so the topology here at this level was not intended to provide any sort of a virtual overlay information. So,
yeah. So now when we move to overlay network, so I think we need to extend this current the topology or current interface which we have. Right? Am I right?
Well, so I guess that depends. So it's certainly not specific to just L2, because we certainly demonstrated we can map the optical topology, for example.
Yes, I agree. So optical and switches between the master.
Yeah. Well, perhaps it may not be directly applicable to sort of symbolic topologies like the L3 view. But the idea here is that the underlying graph can be annotated, and you can extract the various layers from that underlying graph using the various annotations or entity types.
Yeah, if you use annotations information, like maybe we can annotate it and send the information specific to the layers which you are talking about. But when we annotate it, it will be mostly about the keys and values. So this is specific to the protocol which is going to add this annotation. So I'm not very clear, like when it goes to the core, ONOS core. So how does this annotation information has been read, and how the application know what is the key and what is the value for this annotation?
I'm sorry, I guess I missed the last part of the question. What is what? What is the key and what?
No, when you talk about the annotation, it is more specific to the protocol, or it's more specific to the SVA, which add this annotation into the core, right? So annotation is basically some keys and values pair. So key can be anything which we wish. The SVA, maybe in case of BGP, I may put the bandwidth as one of the parameter, and the bandwidth information has been annotated, and I can put the bandwidth as a key and its value. So when it goes to the core, so maybe some application want this information. So how do they represent this key value? So they should know what is the key, right?
Yeah, I guess maybe I'm not understanding the context of the question here. The mechanically.
How do you read annotations from the application?
The application and the provider have to, or whoever's injecting the annotations have to agree on it.
So I guess I was talking about symbolically annotating. I wasn't talking about the actual annotation mechanism. I guess there's a little bit of an overload there. So yes, the annotations, if you're speaking about the detailed annotations, those can certainly be extracted by by anyone, of course, but they are, the annotations here, it's a sort of an escape hatch mechanism that's intended to be able to allow us to attach additional, mostly sparse information onto the various entities, such as devices, hosts, links, and things like that. That's the specific mechanism. And yes, the idea here is that it's not intended to be used like heavily or for information that is not really reasonably sparse in nature. Otherwise, then we should instead extend the model itself. I was speaking, I guess, generically about sort of annotating the graph, not necessarily speaking specifically about the use of annotations to do that. So with regard to, I guess I'm still maybe trying to grasp what the overall objective here. So the idea here is to be able to model the specific specific overlay projections, I guess, of the topology, overlay specific projections of the underlying topology. Is that the case? So in terms of, but I guess I thought like for SD and IP, we were dealing with that through injection of network configuration, right?
Yeah, I think what he's doing is trying to discover layer 3 topology through BGP and inject it through the providers of the subnet, right? So,
but with additional information, like with more stuff than we have in the device model. So, or the port model, or different stuff, yeah. Like he wants to put an IP address, or.
But I mean, so ports, we've extended ports for optical stuff, right? So the ports are extensible. The port number isn't, but the port is. Port number is an identifier.
But I think the issue was in the overlay network or the VPN networks. So that when you build the tunnels that connect from one router to another, our modeling currently you need type to a port, device port, set up this ones. However, for this virtual the tunnels, so your endpoint can be any IP address. So the IP address basically you can be any IP address, right? which is not tied to any specific particular interface. So what Satish want to do is make the endpoint is more abstracted, and not only just tied to the port. He want to do something the high level abstractions. It's make the endpoint the flexible.
So what does that mean?
Yeah, exactly. That's what I'm trying to do. Endpoint should be abstracted.
Yeah. So that's what he's.
Well, we do have a tunnel endpoint, which is abstracted already, right? And tunnel endpoint can be a tunnel IP address or various other. The tunnel endpoint is essentially just a tag interface, so it's really flexible in that regard. But the connection endpoint here is intended to symbolize actually, I guess, physical point of connectivity.
So the point is that the device has an IP, and you don't care which interface the traffic for this particular tunnel enters.
Yeah.
And so you want
the idea is that in the current tunnels, when they build the tunnels, they don't want tied to any particular interface, because the interface flagging the status of up and down. So the tunnels were up and down. So they want to build the tunnels is just independent of any particular interface. That's the whole point. So the endpoint is basically the IP address. Some router's ID.
It's a device, right?
It's a different.
You want to get traffic to a device. You don't care about ports. I mean yeah. Currently today links end at ports, right?
Yeah,
but
sure.
I mean,
But tunnels.
Tunnels.
He's talking about tunnels essentially.
Yeah,
right?
so-
but the thing is,
tunnel
if you want
connect
to
points.
model your tunnels as links in the topology, you need to have.
So you have
Some
so what
endpoint.
you do is you then in that case you have a link. So you create logical links out of logical ports. The tunnel endpoint is a logical port.
Do you want to? Well, yeah, I guess.
Yeah, I think the things that I missed by his I know the problems, the issues was he's talking about. I missed the point that he was his proposals.
Well, yes.
Satish, can you propose?
We're still in the problem section of the
Okay,
presentation.
yeah. So I just
but
okay.
understand the issues first. Yeah.
Okay. Yeah, go ahead. We'll let you go.
Okay. Okay, and for this, I have some two proposals. One is we can have some kind of modeling which IETF is proposing. So whatever the draft information which I showed, we can remodel it, redesign the interfaces and the modeling as per that. So also I saw a web page in our wiki page where they mentioned about we'll be moving towards model-driven approach. So that's basically we'll be using the Young modeling. For the modeling the data store, or also using between the Young will be using for communication between the components, right?
Not
So
sure.
I think
We're going to be using Yang for the device drivers, and we may be experimenting with Yang definitions to essentially as a sort of a service definition of against our APIs. But Core will not have a Yang in it.
okay.
Where that
Okay.
lies.
But Yang,
Fine.
go generate off Yang and compile in one time, or what?
Okay, so I thought if that is the case, we can use this I2RS Young modeling only, so that this can be more standardized way. Okay. So one thing is this modeling will be like more abstracted. If you see over here, the modeling what IETF is suggested for the topology, this is more abstracted way. Like we'll have abstracted only the abstracted information of the which will be visible to the application, and if any applications want to see the specifics of the topology, they can further see the augmented class, and from the augmented information, they can get the information of the corresponding layer. For example, if L3 information, again L3 information is augmented by OSPF topology or ISIS topology, or it can be together with the traffic engineering information along with OSPF, or traffic information along with the ISIS. So this all can be abstracted using this overall the topology mechanism, abstracted mechanism. So current APP, no need to know the specifics of the layer. I think our ONS also currently is being architected like this. But what I see is some of the information about, like for example, the port. So that is present in the abstracted class. So instead, that should have been in the specifics of L1 or L2. So that's my idea over here. So maybe we can keep only the little information which is common across all these topologies or all the network can keep in the abstracted class. So specifics, we can move to the specific classes.
So to be honest, okay, go ahead. Go ahead. I'll let you finish.
Yeah. So this is one, but the disadvantage of this solution is because now it's already been modeled. Our core has been already modeled, so the changes will be huge, and many like OpenFlow and other protocols has needed change for this. Okay, this is one of the solutions. Another one is the solution to which I was thinking is change the port class to the abstract class like termination point. Okay, so make this an abstract class. So whoever wants to extend it, they can extend it, and they can use their specific information in their extended class. For example, if you want the port number in the termination point, that can be in the extended class. No need to be in the abstract class, which is currently present. Okay, and one more is we can add new interface like L3 device description, which will extend the device description interface. So further, we can have the implementation for L3 device description for our implementation, because for L3 information, we need to have the device description, which contains the attributes, and also it contains the prefix information of the devices. So the prefix again is the list of prefixes, and attributes is including the traffic engineering attributes. So all this information has to be fed to the core now. So as you suggested, one way is using annotation. So we can use this parse annotation to send this information. Another solution which I was thinking is we can define a new interface like L3 device description, which extends the existing interface device description. And similarly, we can do this for the link as well. So how we are doing this for device description? This can same thing can be done for the link description as well.
Okay.
Okay, this is the another alternate solution which I was thinking of it.
So, okay, which one of these would you prefer? Just to ask.
Yeah, I prefer solution 2 because this will have less impact to the existing models. But if you see overall, if I see, I may choose. I mean, long run, maybe the solution 1 may be better because it's like more generic and it's more hierarchical way.
Okay, so I mean, at least from my standpoint, I would definitely would agree that it would have to be something along the solution 2. Probably a variant in a sense that I'm reluctant to deform the overall topology model to become basically hijacked by the classical L2, L3, and classical protocols terms.
Okay.
I think it should, just in order to stay open towards the long-term SDN picture, it should be in that regard. And then you can project on top of it any particular views that you want. So the key in here is to make sure that the underlying topology model can carry sufficient, it's sufficiently flexible so that the annotations, I'm not talking again, that it can be annotated in a generic sense to allow these different projections to be derived from it. I don't think the solution 1 is a viable one. First of all, it would result too much complexity, too much deformation, and we do not want to become victims of yang in the core. We want to use it and exploit it, but we will not be victimized by it.
Sure.
So I think what we probably have to do is have more detailed discussions about the specifics of the solution 2. What would be the best way to accommodate it?
The thing is, in L3 networking, right, the ports, like for links, matter less, right? Because you have a protocol for figuring out who your neighbors are and doing whatever. So, I mean, one question is this node-based hopping instead of node port pair decision making. Is that it's sort of a more relaxed notion. And so one thing you could do is you could effectively have like a normal port, right? Which effectively just says like, just use whatever lower level L2 routing stack you want to make a decision once an IP, once you've figured out where the IP or the tag or whatever is supposed to go. So using a normal port could be used instead of actually specifying an explicit port number, or having some like magic ports if you're going to talk about L3 numbers that can be used. The other thing here is it seems like, in the model that was presented, there's this notion of supporting links, and if you want to track like the L3 links are built on top of L2 links, which are built on top of optical or L1 links. That's something we probably want to capture in a different conversation. We have some mechanisms for doing correlation, but doing it in a more generic way might be useful. So, yeah, I think the whole like changing port number class to abstract termination point may not be needed if all you care about is a device ID.
No, for sure. That's why I said a variant of, because I don't think that changing port number itself would be the answer. But perhaps extending the notion of a link to make it not have a variant of it or derivative that does not rely on a specific port number.
I mean, you could put a connect point and just put like a magic port number in, and you have just an element ID, and then you're done. You've modeled your L3 links. So,
but the
I don't know. It seems like here the port number you want to replace with something like an IP address. And if that's the case, yeah, maybe that's an annotation on the link, or is it? Or is it a tunnel?
Well, the thing is, the idea, at least the idea earlier on, and we never pursued it, I guess, or yet we didn't pursue it yet, was that you were going to have links which are going to be backed by tunnels. And so the link is there essentially to sort of act as an edge in a graph, but then the backing information is contained by and carried by the tunnel.
Yeah.
From where you could derive the IP address and things like that.
Yeah. Okay.
So the link would be associated with an L3 tunnel, and that would have the IP addresses at each point.
Yep.
The endpoints.
Yep. Exactly.
Or if it was an L2, it would have a different.
Yes.
Yeah,
And as a matter of fact, we have a type link
model.
tunnel. It's a tunnel link, which implies that it's backed by tunnel. We just haven't, don't have any applications or providers that currently code the information in the model language. Okay, so we should probably then sort of, at least it's a sort of decision, at least for right now, is to pursue the variant of the solution 2, and probably ought to have a more detailed discussions on that topic.
Okay, so now I'll look into the solution 2 part, like more detailedly. Maybe I will come up with some few variants of solution with the solution 2 only. Maybe I'll be sending you offline the mails. Okay, that will be okay, right, to the group?
Sure. Yeah.
And your link tunnel concept that can cover, say when I get a multi-layer graph, right, I might be linking A to B, but underneath.
Yes.
That tunnel is actually a link from A to C to B.
Exactly.
And each of those links are actually tunnels.
Yeah, and notice that, for example, paths are essentially links.
So
Multi-segment links.
I think one distinction here is the links are really they're sort of giving visibility to other services and applications about the existing topology at particular layers, right? Either a virtual topology, a specific slice of a topology, or the overall topology. And so how that link is realized, whether it's actually a physical piece of copper, it's an optical cable, or it's backed by some tunnel, like that implementation, it should be sort of separate from the representation of the link.
Yes.
And so stuffing an IP address in here to the link doesn't necessarily, like if it's part of how it's realized, that probably doesn't belong there. If it's needed for some other reason, then maybe we should talk about like making it an attribute of the tunnel or something else. But it seems to me like it's probably not so important for the person who's visualizing the graph or making decisions based on that visualization. It's more important for the implementation of getting the packets to flow in the directions you want.
So it really matters what the use case is, what it cares about. In use cases, I want A to B. I don't care what layer or what I'm talking about, what the implementation or realization of that link is. Yeah, that's what I'm doing my reasoning. But the intent compiler, taking that might care and look at the tunnel and make decisions on how it compiles down. So
sure, but it seems like what you'd want is if a link is backed by some like collection of other links or something, what you'd want to do is you'd want to be able to inspect the map.
yes.
And you'd want to be able to see the implementation structure. And that would have to contain things like the IP address, specific hops and stuff like that. And so that structure, though, isn't the link. The link class is the piece that goes in the topology representation that you can look at from above.
Again, it matters what the viewer is and what they care about. If all they care about is that abstraction, that's what you're talking about, is abstract connectivity. You're right, absolutely great. The question is, operators that are using ONOS, do they care about the abstraction, or do they care about more detail often or not? I think we want to push them to care only about the abstraction.
Right, but the thing is, these indirect or like tunnel-based links are going to need to be backed by something. And so if you do care, you should be able to dive in and see, okay, well, what is this link supported by, and then get the payload of whether it's a sequence of optical paths and what lambdas and stuff are in use on those paths. And also for debugging, it's really important to be able to see how a link is realized so you can trace and visualize.
And you can also potentially also say, this link has got this is my primary route, and it's got this backup route for if this part of the path fails or this part of the tunnel fails.
Sure.
Here's my workaround. You have behind a single link, the primary and potentially multiple failure scenarios that are all pre-programmed into the system.
But I think that at least the perspective that I have is that the link abstraction should be the high level one, and that any sort of information about backup paths, details, these things need to be available, but they're probably not going to get shoved into the link class. They're probably going to be in a tunnel or some other object.
But the tunnel is going to have to be recursive, because a layer 3 tunnel could be is that really a link to a layer 2 tunnel?
Sure. So it could have a bunch of the tunnel that implements a link could have other links in it as resources that effectively then would be recursively defined.
So an abstract tunnel between A and B turns out an abstract link between A and B turns out to be a layer 3 tunnel between two IP addresses, which in turn really is just an abstract of another tunnel down to the layer 2 layer. So there's really no difference between a link and a tunnel in this case, except the data that it gets as you go deeper.
Sure. So, I mean, the question, I agree with you, but the question is whether do you take that information and do you stuff it in the link class, or do you separate them and have a link class that someone can use to observe the sort of connectivity, and then a tunnel class that implements.
Right, but it's not just one tunnel, it's always that recursive.
No, I understand.
All the way down, sure.
So I'm still trying to understand what the difference is between the link and the tunnel is just the amount of data with it. I'm not suggesting you actually shove all the data and flatten it, but I'm suggesting it really is the same object model, just as data is going down.
Yeah, I mean, it's the same. A virtual link is effectively, a virtual link could be backed by a physical link, or it could be backed by a sequence.
So the top level thing is still a tunnel.
So
it's just a virtual tunnel.
So the idea here is to...
That's true. I mean, even the physical links could be, they're tunnels, right? They just happen to be over copper, right?
Exactly. But the basic idea here is that the graph itself remains very, very simple. Just a graph, which is a set of vertices and edges, with as little other stuff attached to it as possible if you don't want to view that other stuff. But with ability to be able to now inspect the makeup of the individual vertices or the individual edges and drill in, and then you can realize that essentially then you can have sort of a recursive definition of the graph within it.
I absolutely agree. What I'm trying to suggest is not to add two different objects, have a link object and a tunnel object, because they're really the same object when you get down to the code.
Well,
and it's just...
Yes, but there's a separate set of concerns you need to be concerned about. Let's say, so you have a physical link, it's an optical fiber, let's say, and so that has its own set of concerns, which are possibly some concerns are going to be in common with a packet copper type link, but there will be some different concerns. And so the idea here is not to coalesce things into a big bag unless we're absolutely sure.
I agree. There could be some.
Which is why we separate the notion of the graph and the graph edge, and how the graph edge is implemented is kept separate, and there's an association between them that can be traversed for further inspection, and in a sort of iterative fashion.
I'm not getting my point across.
Okay, maybe
I didn't, maybe the wrong form, but I agree with what you're saying. But the issue really is, if I'm looking at it from the abstract edges and nodes, agree. But if I decide I want the view of the L3, I'm still looking at links.
Yes.
And nodes. It's just now my link has a little extra information.
Exactly.
So rather than have I'm trying to suggest not to not to have a different object model for viewing the graph than when I drill down, because it really is a recursive operation. I have a virtual tunnel, then I have a layer 3 tunnel, then I have a layer 2 tunnel, and I have a layer 0 tunnel. And it's all the same tunnel, and it may just be derived subclasses as I go down, if you will, to add data. And maybe subclassing isn't the right mechanism, but it's that type of thing. Rather than say, I have a link, and a link is composed of tunnels. Well, but then there's a tunnel. Well, that's composed of other tunnels. It's a recursive. You have a tunnel, which is composed of other tunnels, which is composed of other tunnels. And so you get that.
Kind of have like a children.
Right. It's rather than have two different objects, because I think they're really the same object when you get down to it. It's just what data is associated with it.
Effectively, a physical link is a degenerate tunnel, and really is a tunnel, right? It's the same sort of abstraction.
Okay, quick question, Satish. On the there's a note on the bottom which says when interface changes, the device link topology manager need to adopt the change. What do you mean by that?
No, actually, when we extend this, when we have a change in the interface, like for example, if we have this, we go the solution 2. For example, the port number class, we are changing the termination point. So this kind of changes should be adapted to the manager as well. For example, if we change in the link, so the link manager should adapt to this change as well to update the store, right? So that's what I mean to tell here.
Oh, I see. Okay. Okay. Yeah, I guess that's basically just the scope of the refactoring, right? Whatever.
Yes.
Of course.
I have questions here. So now is something like it's like this. Let's be back to the legacies. Okay. So they are use separate stores to store the different layers information, right? All these are sometimes it's have any collaboration or association, right? Take a look at the IP plus optical plus the IP plus optical, the graph we used to converge. In that case, it's a physical port in optical, and the ones in the router is the one-to-one, right? So we can do a converged global views. That's no problem. Now the case is that in the it's in this virtual network. Okay, you build the virtual network is on top of the physical ones. You can flexibly map into any of the port, or you don't need map. It's just some things. So here is a couple of things. So the number one is how do you store each layer's information? You use the same objective doing more attributes or some things, or you want to store separately. Okay, is the number one. Number two is we have the device managers. We have the topologies managers, right? All these device managers is how do you figure out you are managing the virtual layers or the physical layers? That is the second question. Where to indicate, like I'm the applications, right? I'm the applications. I know I'm working on the virtual the topologies, right? I create the virtual topology, so that when I send the set up the path or some things, I assume me as an application, I have no idea about your physicals, right? I was just saying, hey, I set up path. It's basically I assume I based on the virtual topology.
So we're straying into the virtual topology, and for that we have a separate subsystem and a separate plan for attack. So what we're dealing with here is just basically just an underlying physical connectivity and physical connectivity graph with some ability to annotate it for along the lines of the classical networks, i.e. L2, L3, and stuff like that. But those are not virtual networks. They're just sort of logical overlays to be able to view things in the classical way. And I want to make sure that the objective here is not to degenerate our general purpose long-term model with the classical viewing stuff. So otherwise, we're going to get stuck in a rut.
But I mean, an L2 projection on an optical network is effectively a virtual network, right?
I understand, but at least what Patrick was at least implying is the virtual network, like actually building virtual.
No, is the VPN network is the virtual network, right?
So overlays.
It's the overlay.
So overlays of any kind, effectively, and they're not just overlays that are edge core overlays, but overlays that, like, you have an L2 or an L3 network on top of an optical backbone, or a VPN network on top of an IP network. I mean, these are effectively virtual networks.
Yes.
Because there may be physical boxes that help realize the virtualization, but they're effectively virtual networks.
Yeah.
And yeah, as Patrick rightly said, actually what we are trying to our ultimate goal is to build the virtual topology only, right? So what BGP and other protocols, link state protocols, so what is trying to build is the virtual topology.
Yeah, I guess I'm stuck, maybe I shouldn't be, but I'm stuck on a term of use virtual topology. I guess I would prefer not to use that, because we have the term for virtual networks reserved for something else, which is where you sort of, it's in a conjunction of a data center and or WAN tenant-based virtual networks. I understand the concept, the fact that yes, the different layers ultimately form sort of a level of virtualization on top of another. Yes, so yes, they're virtual in that sense. But really, at least I would like to use the terminology more like an overlay.
But the question is, as you go down the virtual network path, is there going to be some commonality here with what you're doing with the overlays of the different layers, the classical layers, and what you're doing with kind of the data center virtualization?
Yes, but then you're also going to be dealing with scoping in terms of that you're not going to be able to, you're going to expose just that particular topology, and there are going to be potentially completely different projections on a topology underneath. So there's the different set of, I think there may be some commonalities. Largely, they're going to be very different. And yes, from an application standpoint, we want to make sure that they're as much as the same as possible. So we will be exposing similar services to what currently exists for the regular sort of physical network. So I think right now we're trying to solve the problem of the modeling at the physical network layer, whether it's L1 or L3 or what. So the idea, how do we change it? How do we make it flexible to be able to allow the graph to stay reasonably generic, but at the same time, for those applications that are interested, they can surmise the logical overlays in the classical sense. I mean, that would be the key. And I'm not at all suggesting that how we model it right now is sufficient to be able to accomplish it. So we should certainly be able to look at changing things as needed, but I want to make sure we don't stray from the original goal. And we also don't accidentally stray into the realm of virtual networking, as in, OpenStack and stuff like that. That's what that was my point, Brian.
Sure.
Okay, I think we can, do you have other topics, right?
Yeah.
Has a question.
Okay, so before we move on, there's a question in the room.
Yes. In this time, sort of in the context of solution 2.2, I think you mentioned that we don't want to introduce this technology or like a specific description kind of thing into a picture, but
yes,
sort of in optical port, we already
do. Yes,
and
yes.
Ideally, how do you think that should have been done?
Well, the thing is, I think in an optical sense, we can still stay reasonably agnostic of the optical stuff, right? The provider injects information about optical ports and stuff like that in order to be able to capture the information which is essential for actually establishing connectivity and things like that. So I don't see, while I was actually a little bit skeptical about that approach in the beginning, I think it's perfectly fine. And so we may need to do something similar for L3, but in general, I would try to resist it unless it's absolutely necessary, I guess. Because I'm extremely wary. When I see, especially the slide like before this one, the IETF models, that gives me allergies, because that's like the classical networking hijacking SDN. And that I get immediately suspicious. And I don't care what standards body you put on it. Really, I mean, I'm a software guy, I'm not a networking guy, and so I get suspect of these things. So I have maybe different viewpoint on this.
So to some extent, it's okay that those technologies sort of lead into the manager and store.
Yeah. Right, yeah. Exactly. Okay, so did I answer your question?
Yeah.
Okay. So thanks, Satish. Thanks for humoring the discussion here. I think we can probably move on to the next point.
Sure.
Topic.
So next one is regarding the mastership management inside the clustering. Okay, inside the cluster. So this is the I took from the wiki, and according to this, we have something. We have like states like none, standby, master. So the device which has direct control, which is directly having the control connection with the controller, so can be chosen, can be either master or it can be standby, and all other things which is learned, maybe through other cluster, maybe as none. Okay, so this is how the current mastership is being done. So now the question is, we'll be having one BGP session with the network. So through this single session, maybe I'll be populating some hundreds of devices, so which are not directly connected to the controller, right? So it will be like just I'm pushing the topology information to the core. So and also if you see the interfaces, it says device is connected. So when I push the information using this interface, saying the device is connected and giving the device descriptions. So actually, how does the mastership management work in this case? Will it be like chosen as a none, or will it be considered as this is direct connection? So I just have a little bit doubt on this aspect now.
So the mastership for each device could be managed independently, and there's only going to be one candidate for each of the devices that are connected, which is namely the node that has the BGP-LS session established.
Yes.
And so it should just all fall out. If you have another BGP session that you start on another node somewhere else that has access to the same set of devices, then that second node would become a candidate for all of the devices that have been detected as a result of BGP. And then you could load balance if you want or not. But ultimately, the ONOS instance that has the connection, the protocol connection to whomever can control the devices should be the master.
Yeah, but I have only one physical connection with the device which is running the BGP in the network, but it gives the information about all other devices. For example, consider there is some 5 devices A, B, C, D, E in the network. So only the A device runs the BGP, but it populates the information about B, C, D, E. So how does the B, C, D, E devices being treated here inside the cluster? So will it have the masters, or it will not have the masters?
The BGP-LS provider, if it decides to register devices B, C, D, E,
yes,
register them, it'll be the only instance in the controller that has a control connection, albeit indirect control connection.
Yes.
So it will be the master for those devices.
Okay. So this point is not a problem to think or worry about it, right? So that's what my concern. Whether I need to look further into this aspect, or is it fine whether we have the logical control connection? It may not be physically, but logically you have control connection through the BGP protocol.
Today we have null providers, which are, like you basically inject it on any node, and the place where you inject is the only candidate, and it can only be the master.
Yeah, and it's also sorry, Bob, but it's also predicated on the same provider properly treating the row request that comes from the core, because the in response to device connected, there will be an immediate role request sent downward to the provider, and there needs to be a proper treatment of that in order for the mastership to actually occur.
Right. And that role request will only come from the location where this call was made.
Exactly.
So that is the only candidate that can vie for mastership.
Okay. So then,
there's a question.
Yeah, it seems that there something I don't understand about this slide. Maybe someone can explain it. Is that there seems to be a two different kinds of mastership. One is the mastership of switches and I guess data plane devices, and the other is mastership of a control plane device. In this case, the BGP session. And it seems like a mistake to sort of conflate those two, but they don't seem to be the same thing to me.
Well, so the mastership we're talking about here is the mastership of devices. These are devices that don't use OpenFlow to connect, or Netcom or some other protocol to directly connect. They connect through a relay node. You have one BGP session, which is effectively your control protocol, and then you have a number of devices that are discovered through that single session.
Okay. So there's just to differentiate, you're talking about the mastership of the switches.
That's correct.
Not of the BGP session, because that was something that didn't fit well into my
it's the mastership of the switches.
And so I guess the question, I think, which Satish is trying to ask, if I understand it correctly, is how is that load balanced across multiple nodes, and what happens during failover?
Right.
It's a good question.
In particular, what happens if the node that has the BGP session goes away, and then the topology changes? How does a new session get created? How does the topology get updated? And also, how does the load across those devices get distributed across nodes?
That's a good question. My assumption was, I guess, just sort of interesting assumption was that there is actually multiple BGP connections, and there is a separate leadership contest for who's actually going to be considered as a primary. And
well, as far as the BGPLS connections, you can have arbitrarily many.
Right.
You could have one to every node if you wanted. And the question is there an overlap in the set of devices that are advertised? And as long as there's some overlap, then you can handle a failure of the primary node. And then if a node happens to be registered or provided effectively to the core from multiple vantage points, aka multiple connections, then only one of those providers is going to be elected the master for commands for a particular device.
Yes.
So the BGPLS sessions are somewhat irrelevant. There doesn't need to be a mastership per se around those. It's more the devices that are going to be controlled using that provider.
So you're saying that there can be multiple BGPLS sessions?
I'm not sure what the model looks like. So my assumption is that they're either going to have a single session with a bunch of devices around it,
right,
and then, if the failure happens, they have some protocol for picking another device to connect to, or there's some multiple vantage points where you can have some degree of overlap.
And both are supported today, right?
Both would be supported.
Similar to the active standby connections with an open flow switch.
I guess what I was picturing. So I understand that there could be multiple. I'm just picturing sort of what, in the context of the SDNIP does its own leadership for action for other reasons necessarily, not the mastership of device.
Right.
So I guess
that's more for the routing table.
Exactly. The question that seems to be asked here, it says no mechanism to tell whether it's directly connected or learned some feature, and about clustering. It seems that there is this case where you learn the topology through some a priori mechanism, whether it's something, a provisioning database for data center or something. And the question is, how is that updated or maintained in the case of failover, where the device, the node that was talking to that database or that external system goes away? How does it restart, or how does it get reconnected somehow?
And so this is precisely why we structured the providers as we did, is just to sort of have a very high level language and level of interaction that we're dealing with the core, and what southbound protocol you put there, whether it's even facing south, it can be facing sideways or even upwards, like to an OSS system, right? That can feed this information externally. But of course, if it wants to act as a provider, it's under obligation to satisfy certain interaction requirements, and they're fairly low and few. But for example, one of those would be to tell us when a device goes offline, so to speak. So there will be device vanished or disconnected. I forget what it's called exactly. So Satish, so as far as the explanations that Brian provided, would that work for you?
Yeah, I have one more question here. So even though you choose, okay, consider a case like even though we don't have physical connection, so we have the logically connection like through BGP. So you discover some of the nodes, and you define a mastership. So still, this mastership doesn't make any sense because you don't have any direct connection, and you cannot do anything with the device. You don't have the direct connection. Maybe you don't have open flow connection with the device altogether. So in that case, how does this mastership will help us? Like even though we choose as a master, I mean some of the instance as a master for this device, so it doesn't actually make sense. I cannot interact with the device because I have only one BGP connection, and there is no way by which through the controller I can interact with that particular device.
So that's a limitation of the control protocol, right? So the
yes,
idea is that just because we say you can use any protocol to interact with the devices, what we also say is ultimately depends on the capabilities that you can convey over that protocol, and whether it's a limitation of the protocol or limitation of the devices, ultimately what you can do with the device is going to be limited by the capabilities of the device and the protocol. And so if you can discover devices, that's great. But like you said, if that's all you can do with them, then it doesn't really do you much good. If you can't program their affect their.
Why do you care, right? If you can't control it, why do you care whether you have master or not?
Exactly.
You can still see the device.
Exactly.
Right?
Yeah.
And that's what you're getting at.
Exactly.
Yeah,
That's precisely
Yeah,
right.
it's not particularly meaningful in the case where it doesn't actually do anything. It might mean something like, well, this node is responsible for determining whether this device is still connected, for example, which that might be meaningful. But it certainly, with a degenerate control protocol, it's perhaps not as important as it is with something like an actual SDN device.
I mean, the provider could also, if it realizes that the device is no longer being advertised, it could report the device is disconnected, and then if the device is being reported by someone else, it'll be.
So I don't think there's any harm in reporting mastership. It's just that ultimately you will hit the limitation of not being able to do certain things.
Yeah, I got it. But can we do something like we can, as through this SBA, we can inform to the core whether it's having the direct connection or is it learned through other means indirectly?
Well,
so
it
that
doesn't really have anything to do whether it's directly or indirectly. What it has to do with what you can do against the device. It's the actual control capabilities that are on hand for that device. That's really what's important to the application. The fact that you're connecting through directly to the device or through a chain of 5 different proxies, it's really not of consequence, right? What's of consequence is what you can do with the device.
Correct.
So if you want to convey to the application that device is there and it's up, but there is no master, well, in that case, you could probably just refuse the mastership, and then you can still report on, or you could have an auxiliary provider where you can basically inject the information about the devices and links into the system, but ultimately you can't really report on other things.
Consider a case like where applications sees that there are some devices which are connected, and it also sees there is a mastership for the devices. So application want to inject some, for example, some rules or some information to the devices. So basically, there is no control connection to the devices. So applications try to inject, and application sees the false information saying that this device, this instance is a master. So this gives some kind of false information to the application. That's what I mean to tell over here. So instead of that, can't we give some information like these are all indirectly connected? There is no physical connections, or there's some kind of information to the app, so that the app is aware that they cannot control or they cannot interact with these devices directly.
But the thing is, it doesn't seem to matter, right? Like the thing is, normally you don't have a physical wire directly from your switch directly to ONOS, right? You have a control plane network that's got either L2 or L3 boxes that sit in between. So, you know, if your control network happens to fail and you don't detect that for whatever reason, then you can't control your OpenFlow switches. And eventually the heartbeats will time out and the OpenFlow provider will realize, okay, the device is gone, and it will disconnect and no longer be the master for it. But it seems like the same thing here. It's, you know, you have a device that you happen to discover through, you know, some proxy. And if you're able to figure out in the future that you're no longer able to see or detect the device, then you just report it as disconnected, and that's all you need to do. Maybe we're missing something on our side.
No. Oh, yeah, I got it. What you're telling, but what I am trying to clear is like, yeah, I can connect and disconnect. That's not a problem. But what application sees over here is that, for example, instance X in a cluster can control B, C, D, and E devices, right? So it thinks that I can use the instance X to control the devices B, C, D, E, but controller do not have the any control protocol below, like OpenFlow or something, to push the information down to the device. It's only get the information from the network. It doesn't have. If you take the BGP LS, so it only fetches the information. There is no currently there is no mechanism to push the information. Maybe in future using the BGP flow spec or something, we can push the information. But at the current moment, the application will think that will see that they have a mastership for this device, but they cannot push any information. They cannot send any control information to the devices.
This, yeah, you'd explain to that you made two statements, but you haven't provided a logical argument as to how they're connected with each other. Which is that usually applications don't care what the master device is. And applications do care what they can do with the device, but if they're using an object which doesn't support a particular interface, well, obviously they can't use that interface.
So we have a couple of possibilities to signal to the applications that they shouldn't attempt to do any control, exercise any control, such as push flow rules or request packets and things like that. And so, sorry about one more thing. Today, we usually, most applications rely on a mastership. They usually attempt to control the device directly, only if you're a master. Now, of course, there's exceptions to that.
The applications
Which applications?
Yeah, the applications don't directly do that, right? It's usually there's some effectively abstraction.
Yeah, I guess something network services. Sorry,
Sure.
not necessarily. So things. So
yeah.
networks. So yes, you're right. Stand corrected. So the network. What I was really thinking of network services like packet request manager or components like that. They usually funnel the requests from applications to the master, and since there's no master, it's not going to get funneled anywhere. But you can't do anything, and so I think that's what.
The problem that applications don't know the differences between the BGP devices and say OpenFlow devices, and so they try and do things with.
Yeah, I think that's what Satish is concerned about. Is that basically they just see them as devices, and now they try to exercise control like they would normally against other devices, where there's an assumption. I guess maybe the problem lies with the assumption that once you can discover a device, you can do things with it, usual sets of things with it, and then. Clearly, if we have a provider that cannot make that happen, then you're gonna be getting some exceptions and anomalous behavior. Yeah.
So I think a logical. I mean, the behavior I would expect as an application programmer is the object I get would be of the appropriate class, and if it's an OpenFlow switch, I can program it with OpenFlow. If it's some other kind of switch, well, I can't program it with OpenFlow. If it's a P4 switch, it'll have specific capabilities. If it's a traditional L2 switch, then maybe it has static map programming.
Yeah, so we're not using an object model per se, we're using sort of like a type model where we have device is a device, period. It has a URI, and if you can be generally, the idea here is that applications are completely agnostic of the URI, they just use it as a sort of a unique identifier key. But the URI, the scheme of the URI is used for downward delegation for operations that are targeted against that device. So to do appropriate provider. The problem is if the provider can't provide those functions, then things break.
You just get an exception.
Well, again, that depends on what the behavior provider is. If there's no provider to delegate to, then you're gonna get the detention subsystem. I'm thinking you're gonna get exceptions, but I guess that would depend on the
There would be a
service
BGP
provider.
provider with probably no implementation.
Right, exactly. Yeah, so one possibility to indicate to applications that their requests have met demise would be to implement providers for flow and packet subsystems to basically throw exceptions when the requests are delegated.
Okay.
And so to answer Bob's question about sort of the object-oriented approach, that is more used in the elastic area of the device drivers, where you can actually inject facets of behavior, and there's essentially object-oriented like behavior, where you can actually say, does the thing that I'm looking at, does it do this? And if so, great, I can use it. But this thing doesn't do that, so I can't do that.
But even without going all the way to the provider, is it better to inform the application that you cannot perform these operations on these devices, though they are all the masters of this instance?
Yeah, I'm reluctant to add additional complexity, because then it really then you start getting into capabilities of providers and stuff. And the whole idea is that if you want to provide a provider, the suite of providers should provide full suite of functionality, control functionality, even if it means resorting to use of hybrid protocols. But if you're just simply reporting on what the topology looks like without any ability to affect it, it's of some use, but probably of limited use. And I guess my suggestion would be here, I guess applications then need to be cognizant of the protocol.
That
the URI.
That seems like the core issue, right? Is that if you're building, an SDN system on top of non-programmable devices, that most of your applications are not going to be able to do anything useful. So it's just kind of a sort of semi-pointless.
Yeah, exactly. I don't want to introduce complexity to tend to that edge scenario, which maybe not so edge now, but in the future it should be.
But I mean, effectively, what you're going to do is you're going to have a BGPLS device provider, and you're not going to have any other providers, right?
It would be device and link, right? It would be device and link provider. Yeah, you won't know about any hosts. You won't be able to have a way of pushing flow rules or intercepting packets. Yeah. Yeah. Yeah, so my suggestion here, Satish, would be that if an application needs to be aware of what the device can or cannot do, I guess it can then be aware of the schema, the URI schema, and make differentiation based on that, or receive exceptions.
Okay. Okay, got it.
So the one question here. So how do we support this HAs? So in such case we are. Now is Satish was just talk about the one links, right? You collect the topology, so talk to the one instance. So in the HA case, so the multiple points, multiple connection is established between the ONOS and
that would be the HA solution.
It's a
multiple BGPLS sessions, or have the session be able to talk to multiple controllers.
In such case, it's ONOS only take care of the masters. You can take both. So in such case, the solution is what? Can what Thomas you suggest the cover distance?
Well, Brian touched on it, right? You have multiple BGP sessions, or at least multiple connections between the different ONOS controllers, and whichever ONOS controller learns about the same device, it now becomes a candidate, becomes either a standby or a master. And if it's a standby, then it's a potential master in the case of failure.
Automatically detect this one. Probably we can use a CRI command or some policies to specify. Here is a master, here is a slave.
No. All you need to do is just have multiple connections that can see overlapping pieces of the network.
Exactly.
Yeah.
That's it.
Okay.
If you have multiple vantage points that can see overlapping segments of network, then the device will be reported for multiple locations.
And a master will be automatically selected from one of those.
Okay. Wait.
Yeah,
And if
and
one of
if
those
you
fails,
have
then the other
multiple views of the same device, then one of them is the trusted view. That's the master side, and if it disappears from that view because that vantage point disappears, then you'll collect information about that device from another vantage point.
And you'll have highly available no control, as we discussed. Because you'll have highly available visibility, I guess, right?
Yeah. I think I need to think about it because a couple of the scenarios is like especially for the two domains, the boundaries. So you see the overlaps. so okay, maybe we can at least think about it.
But we have this now, right? One open flow switch connects to multiple controllers. Maybe like the master and what is the same thing?
Yeah. So I think we're actually almost 90 minutes in. So you said you had a topic.
Thomas, only one more point is pending to discuss, one slide. So maybe I can close.
Let's
quickly finish it. Yeah. So this is regarding the UI changes. So now we will be update our topology should have the capability to give the details of L3 information as well. For example, the any of the L3 information about the interface or the IP address or its attributes or the T properties, anything. So so for our demo as well as for in the future, so user or through the web UI, when we want to display the information about this topology, what we learned through BGPLS. So maybe I want to give, I want to see all the information which I learned. Maybe it can be through the annotation or through any mechanism that we'll decide later based on the detailed solution. But this information should be shown to the user in the UI part, whether it's CLI or the REST API or web GUI, right? So this part also might require to change to show this detailed information to the user, right?
Okay.
So yeah, so this part I want to know like whether we need to change it or we can take or we need to. I don't know the process for this, like how to do these changes. Whether since we are updating this topology, so we can take it up and change it and check in and commit it, or how does it work?
Well, no. So, the ONOS UI supports adding additional views, but it also adds allows adding overlays over the existing topology. And in the overlays, you can highlight nodes and you can highlight links, and you can suppress others over the same topology and you can switch between the different overlays. So there's a mechanism for this. So my suggestion here would be to take advantage of that new capability and develop a brand new separate overlay that would allow you to visualize, let's say, L3 connectivity, if you want, or optical connectivity. Or
okay.
It's basically, we're talking about just selecting and picking pieces of information from the underlying graph and using those to visually differentiate elements of the topology.
Yes, exactly.
Topology.
So this point we can take it and we can change it, or how is it like? Because maybe is there any specific owner for this part, or?
Before just running blind with this, I would suggest again. So let's set up a meeting with perhaps Simon and I, and we can give you demonstration of the existing capabilities.
Okay.
And how to go about that, and maybe we can discuss the specific requirements separately, because it could very well be that there is some limitations of the existing overlay, and then you may need some additional extensions. But rather than doing that all by yourself and in isolation, I would suggest doing that in coordination with our team here.
Sure.
Okay. So just like dealing with that scenario 2 of extending or augmenting the topology model, you should be working with the people like Brian, Ali, and myself, or Jono, And then Madan possibly also if it requires changes to the stores. And similarly, would be working with Simon and myself if it requires changes to the UI. But I would first start by just getting some demonstrations and overview. Because this capability is new. Simon's been working on making sure that the wiki page has been updated, but there could still be possibly holes in our documentation, and so you would probably benefit from a sort of an in-person demonstration of the capabilities and explanation of how to go about enhancing it.
Sure. Yeah, that's it from my side. Thanks, guys. And regarding the first point, the solution part, the solution 2 part, I'll be further deeply analyze this. Maybe I'll be having more one-on-one discussion with you guys in future. Okay. So I'll be sending this shortly. Maybe this week I'll try to finalize this and send it to you guys so that we can discuss and finalize it quickly. Maybe in the sprint 2, we try to close this issue, right?
Yeah. So the idea here is try to aim for as little disturbance to the existing model as possible, because we're limited by number of factors here. We're limited by time because we have our core record. Also, we're limited by backwards compatibility because we can make changes only in a sort of evolutionary manner across a single release boundary. So we won't be able to just refactor stuff and throw away everything else, because that would damage the, that would break the API, and that's something we want to avoid. So we want to evolutionarily move forward.
Sure. Okay.
Keep that in mind, and for the UI, I think that you should be able to get you started really quickly.
Sure.
Okay.
Okay. Yeah. Thanks. Yeah.
All right. Well, thank you.
Thank you.
I think we're out of time, so we can probably close this out. Thanks, everybody. We'll see you next week. Thanks, Satish, for staying up late. You understand?
Yeah, sure.
Wee hours in the morning there, so thanks.
Yeah, that's okay. Yeah. Thanks, everyone. Thanks so much. Thanks, Patrick. Yeah. Bye-bye.